Frédéric Thomas, good evening. You are a CNRS researcher housed in IRD offices and a specialist of parasitic transmission strategies. Can you explain to us what we just witnessed?
It is one of the most spectacular instances known of behavioral manipulation of a host by a parasite. Nomadomorph hairworms, when juvenile, are parasitic in arthropods, mainly terrestrial species, including insects such as crickets and grasshoppers, and spiders. But they are free and aquatic when adult. During their development, they grow from a microscopic cyst to a huge worm whose size often exceeds that of the host by a considerable amount. Once they reach this stage, they alter the behavior of the host by making it commit suicide by jumping into water. It can be said that an infected grasshopper, for example, that jumps into water does not do it willingly. Rather, it is the parasite's genes that are being expressed in the behavioral phenotype of the infected host and instruct it to jump. To study this phenomenon, we used an approach known as proteomics, carried out by David Byron, a postdoctoral researcher on the team. The main originality of this work, performed so far on crickets and grasshoppers, is that because of the huge size of the parasite, it has been possible to simultaneously study not only the proteome of the host, but also that of the parasite at 3 strategic stages of the phenomenon: before, during, and after infection. These studies have resulted in the identification of mimetic proteins produced by the worm. That is to say, proteins comparable to those existing in the nervous system of the insect. Furthermore, we have empirical proof that these proteins are physically present in the insect's central nervous system. Hence, the parasite is able to induce these proteins directly. Where the research becomes interesting in terms of public health is that we have known for some time that vectors transmitting diseases to humans are themselves manipulated by pathogens and parasites, often in ways increasing the vector's appetite, which means they will bite more often and therefore increase the incidence of transmission. It is surely a radical change in perception from an epidemiological point of view if we admit that an infected mosquito bites more than a non-infected one, or that an infected host is more attractive to the vector. Similar approaches can be transferable to other models. For example, in collaboration with the team of Gerhard Kuhne and Sophie Ravel, in which the same methodology has been applied to the tsetse fly and the sleeping sickness it transmits, the result of infection with various kinds of trypanosomes, and with mosquitoes and malaria. In addition, we plan to use the same methodology to work on the triatomid bug that also carries trypanosomes, which cause Chagas disease in humans.
Très bien, merci beaucoup.